Myself, Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to have a discussion on definitions and terminology in Module 4, Single Phase Transformer. So, total here we have the Module 4, the 6-phase transmission line, single phase transformer. So, total 15 questions. Why the majority of power transformers in use throughout the world are filled with oil using a mineral oil. Here we are using oil as a main purpose of oil. So oil is used as a insulation purpose and cooling medium to conduct the way of losses. Here in the transformer, so losses will be produced. So losses which are produced in the transformer in the form of heat. So here there are iron losses and copper losses are generated because of uh, iron core and armature, iron core and transformer winding. This is the core, transformer core and windings. Because of winding resistance, there may be armature, there may be a winding losses that are copper losses, and because of armature core, there may be a iron losses, that means core losses. So this core losses produces the heat in the form of heat. This losses in the form of heat here. Now here this for cooling purpose. For cooling purpose, we will use oil, and here the insulation purpose also we will use. Here the majority of power transformers, the electric material used is here oil, so which serves as for dual purpose. For two purpose we are providing, for insulation purpose and for cooling purpose. Cooling purpose means to compensate the heat because of losses. And second question, mention the purpose of transformer core. Here the transformer main core, this is the transformer core. Main purpose, two windings. So this is the symbol. Primary winding and secondary winding, N1 and N2. Now, so what are the functions? It provides, first function, it provides the low reluctance for magnetic flux linking with primary winding and secondary winding. So if you give AC supply to the transformer and current flows in the primary winding, this current setups the flux in the primary winding, and this flux links with the transformer core, and this transformer core circulates this flux and it links with the transformer secondary winding. And here this transformer core provides low reluctance path. If low reluctance path means there may be a high amount of flux passing through it. So it provides low reluctance path. So this transformer core provides low reluctance path, this flux primary winding, linking flux primary winding and secondary winding. And transformer core experiences iron losses due to the eddy current and hysteresis currents flowing within it. So in turn show themselves as a heating of the core. Here because of eddy current losses, here iron losses are core losses. Means iron losses, core losses equals to hysteresis losses plus eddy current losses here. So main purpose of transformer core is it provides the low reluctance path. So because of this core, what are the drawbacks? So it generates the iron losses, core losses, that means hysteresis losses and eddy current losses. Third question. So transformer windings are generally made up of with copper. Why? So here copper properties here. So copper is the best conductor. So because of that reason, so transformer windings are made up of with copper here. So why? So in order to avoid the losses due to loading current, first loading current, so winding materials must be chosen wisely. So here, so losses means I square R. So I square R means, so here losses means I square R. So this current must be, low only. Current must be low only means that resistance should be high. That copper material properties high conductivity material by some industrial process. Here, windings are made up of copper, or more precisely saying they are made up of high, because of this high conductivity property. High conductivity of the copper, we are using this copper as a transformer windings. Next, fourth question. Before using oil in the transformers, so insulation materials involved. In the previous, we use at the time of discovery of transformer, so the people were using, before using oil, so first one is the asbestos, and second one is the cotton, and after that low grade pressboard in air for insulation purpose. So main here oil purpose is for insulation purpose and cooling purpose. So earlier there is no insulation purpose, cooling purpose, only insulation purpose. These three materials they were used. Further, craft paper was invented, which become much popular, which became much popular insulation material. Now here, fifth question, mention the function of transformer. So what is the function? So transformer, its step up or step down function means transformer is a static device. It transfers electrical energy from one circuit to the another circuit without changing any frequency. That is transformer definition. It works on the principle of mutual inductance concept. So here, this is the core transformer primary winding, and primary winding turns N1 and primary winding turns N2. This is the load. This load voltage is V2 and this supply voltage V1. So the winding which is connected to the primary is known as the transformer. That is, which is connected to the supply is known as primary, that is primary winding, and the winding which is connected to the load, that is known as secondary winding. So that load current is I2. If you connect the load, this current is the I1. So now here transformer does not work on DC supply. It works on only AC supply. If you give DC supply, transformer primary winding will burn. So now it operates on only AC. Therefore, we can step up and step down of level of AC voltage or AC. We can increase the voltage level or we can decrease the current. We can increase the voltage level or we can decrease the current level, or we can decrease the current voltage level or increase the current, step up or step down by keeping frequency of supply. Frequency should be constant and flux should be constant. Supply unaltered of secondary side. So here, without changing any frequency, transformer electrical energy, it transfers electrical energy from one circuit to the another circuit. It will increase the voltage level or current level, or decrease the voltage level or current level. Now, mention the insulating material that can withstand the highest temperature safety. So mica. So that insulation material is here, mica is extremely stable when it is exposed to moisture and extreme temperatures to maintain superior electrical properties as a insulator. Here mica material is the insulating material, and the mechanical property of mica. So what are the, why we are using this as the insulating material that can withstand highest temperature safety? So what are the limitation? It allows it to cut, punched and stamped and machined to close to tolerance along with the maintenance of high thermal conductivity. So it is having high thermal conductivity. We can allow it for cutting purpose, punching purpose, stamping purpose and machining purpose to close the tolerance along with the maintenance of high. Next, seventh one. So which part of the transformer which is visible from the outside. So what are the visible parts of the transformer outside? So only windings and yoke and core. So transformer core, primary winding and secondary winding of the transformer, then load are visible parts of the generally closed filled with air. There is it will not visible. And coolant provides generally provides electrical neutrality also. Thus, only brushings are visible from the outside. Here, brushings. Which type of flux does transformer action need? Time varying flux is required here. So see the here. So transfer electrical energy in the transformer. So it transfer it from one winding to another winding. It transfers electrical energy from one primary winding to the secondary winding entirely throughout the magnetic medium only. It does not have any electrical contact. So it is having only magnetic medium, is known as transformer action. Therefore, transformer action requires, so here alternating magnetic flux, AC flux or time varying flux in order to transfer power from one circuit to from primary to secondary. So E is directly proportional to the d phi by dt. So time varying flux must be required to transfer from one circuit to the another circuit. So from the mutual inductance concept, it will transfer since induced EMF in the transfer winding is due to linkage flux. Next, ninth question. Name the type of transformer that will have only one magnetic flux path in the circuit. There are two types of transformers. So core type transformer and shell type transformer. Core type transformer is this one, and this is core type means core. So two limbs. So vertical part of the transformer core is known as limbs, and horizontal type part of the core is known as yoke. And these two are. In case of shell type transformer, three yokes, three limbs, and three limbs, three limbs here and here two limbs. Now here in core type of transformer, that is having only magnetic path. But in case of shell type transformer, three magnetic paths, the three magnetic flux paths. Here in core type of transformer, winding placed on core limbs, and here, so while in case of shell type transformer, the winding is placed in the mid arm of the core. So winding is placed in the mid arm of the core, and other limbs will be used as a mechanical support. And here in the middle, here core is windings are placed in the middle of the limb only, and other limbs will be used as a mechanical support. This one. And core type transformer have only magnetic path. Flux flows in only one magnetic path only. Here the core type is the best one. And 10th one, mention the thickness of laminations used in the transformer. Why we are using laminations for transformer core? To reduce the eddy current losses. Here the thickness, here the laminations are made to reduce the eddy current losses are made up of thin strips. Generally, steel transformer laminations range 50 to 50 for 50. So 0.02. This is the answer. 0.25 millimeters to 0.5 millimeters. If for 60 edges, so 0.17 and 0.27 for 50 and for 60 edges. So 0.25 to 0.5 millimeter and 0.17 to 0.27 per millimeter for 60 for 50. And next, in the transformer, which winding has got more cross-sectional area? So which winding means here copper or aluminum. Copper winding means aluminum. So here the wire used carrying conductor in the transformer, that may be either copper or aluminum. So if you use aluminum, while aluminum wire is lighter, so and less expensive than copper, but here large cross sectional area of conductor, so must be used to carry same amount of current as a copper. Here, next, what could be the voltage of primary winding of the transformer? So here V1 by V2 equals to E1 by E2 equals to N1 by N2 equals to I2 by I1. So this is the case. Now if you see the answer, so primary winding used in the transformer core can be higher or lower potential depending upon the number of turns only. So this that voltage is directly proportional to the number of turns, and for step up and step down transformer primary winding will be lower and higher. Lower step up for lower, and for step up for lower primary voltage, and for step down for higher potential. That is good. Which winding has more number of turns? So here high voltage winding will always have same thing, V1 by V2 equals to N1 by N2. So here more number of turns means, so high potential, high voltage winding, the winding which is connected to high voltage, means if it is a high voltage winding, there are two types of winding, low voltage winding and high voltage winding. If it is a low voltage winding means less number of turns. If it is a high voltage winding means large number of turns. Voltage is directly proportional to the V is directly proportional to the number of turns. Number of turns. If large number of turns is present on the primary side, and that is step down. If less number of turns present in the primary side, that is step up transformer. Next, 14th one. If the secondary number of turns is higher than primary turns, so here same thing, N1 by N2. So N1, N2 is greater than N1. So what will happen? If it is a step up or step down. So when secondary number of turns is compared to the primary, so voltage is induced in the secondary winding will obviously high. So V2 is greater than V1. So this is, so step up. So this is the V1 and this is the V2. This is the V2. This is the transformer. So V2 is greater than V1 means here voltage is increasing. So it is a stepping up transformer. So if secondary number of turns so higher than the primary, so that is step up transformer by keeping frequency is always constant. Next, last question. So 15th question. So 1-to-1 transformer means N1 equals to N2. So here, so transformer have primary winding having N1 number of turns and secondary winding having N2 number of. If both turns are equals, primary winding turns and secondary winding turns, so that is 1-to-1 transformer. We can call it as this one 1-to-1 if having equal number of primary and secondary turns. Then the transformer is known as 1-to-1 transformer. So thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.